welcome back to Internet Report's Pulse Update, the bi-weekly podcast where we discuss what's up, what's down, what's working and not working, and generally keep our finger on the pulse of how the internet is holding up week over week. This week we're going to be chatting about the application outages and failover systems. So let's start with the download, which is a quick TLDR summary of what happened over the previous couple of weeks. We often see in web application issues that some part of the app will load, even if nothing behind it works. The service is often reachable but unresponsive beyond rendering a basic front page and sometimes an accompanying error message. This is often on purpose or by design. In web application development, it's preferable to be able to load part or all of a UI or front page instead of displaying just a 400 or 500 error message in its place, which in turn prevents the page from loading or calling other dependencies. In other words, part of the application is still able to function. We can get the main part because these dependencies in the back end. Still, this strategy can raise a lot of questions for users of these web applications or services. Just because some parts of an app are available or doesn't mean the entire thing is actually functional. Now, we saw this play out a number of times over the past fortnight. In Australia, the CBA, the Commonwealth Bank of Australia, one of the country's largest banks, experienced a near full-day outage of its digital properties, such as your online banking. The problem left customers unable to transact or even view their bank balances, which displayed as $0 in many reported instances. Now, there's no official explanation of the bank's problems, but from our vantage point, it appeared that there was some form of connectivity issue within the bank's back end, so essentially within the data center at that first hop. And this left its web and mobile apps unable to call or display account data. So this is where we talk about those functional dependencies being able to pull information in. So and that left the payments being sort of knocked back to a result. In a similar boat this fortnight was Microsoft, which made a configuration change to its Teams collaboration platform, and this caused users to be shown a message that operation failed with unexpected error. This appeared to affect users globally, but we're going to dig into more of this in the under the hood section there. And finally, there was a third case of front-end loading but back-end failing, with GitHub users experiencing a nearly 45-minute disruption on June 29th. In this case, GitHub's page rendered normally, but the back-end service or systems or products the user was trying to run from GitHub just wasn't reachable. And again, we're going to discuss this a little bit more later in the podcast there. On the same theme, there was another instance of a failover mechanism failing during the fortnight, with the UK's emergency services calling system going down. The system's operator, BT, has published a detailed post-incident report. The system backend comprises of three clusters, what it calls triple resilient network architecture. A fault in one cluster, it was unclear which, led to BT to switch traffic to a backup system, but the call transfer process failed. It then tried to stand up one of the primary clusters to take production workload, but unknowingly choosing the faulty one. This incident actually highlights a couple of recurring themes we often chat about during the podcast or Pulse Update blogs. First, there's often and never a good time to run live tests for always-on or mission-critical workloads. I often talk about this from the perspective of SaaS applications with a global customer base. It's always someone's business day. Someone will always be inconvenienced. In this particular case, the 999 phone number is a critical service, and even with multiple primary systems, it was unable to handle a particular edge case thrown at it. This raises a second key point. When building a system that can handle every extreme scenario is simply not viable. It would be cost prohibitive as well as impractical. And that's part of the reason why having just a robust response plans in place in case something unexpectedly goes wrong is really important. And then having the visibility you need to quickly identify the source of a problem so you can implement those plans. Rounding out this episode's TLDR, parts of Florida experienced a cable outage on June 17th, which is said to have impacted tens of thousands of residents. The root cause was suspected to be a damaged cable on the Comcast network. As with most instances of cable damage, the impacts tend to be localised to a specific area. And that was the case here, although it did seem to radiate somewhat, with the outage conditions appearing on Comcast downstream nodes, although connectivity and performance in these areas didn't seem to be significantly impacted. As always, we've included the chapter links in the description box below, so skip ahead to sections that are most interesting to you. And if you haven't subscribed yet, we'd love it if you'd take a minute to hit the subscribe button now. It really helps us out and also makes sure that you're the first to know when a new episode drops. If you have any questions, please email us at internetreport@thousandeyes.com. We always welcome your feedback, questions and suggestions. And joining this week is one of our regulars, Tobia, Technical Marketing Engineer here at Thousand Eyes.
Thanks, Mike. Glad to be back.
Great to have you, mate. And now let's take a look at the overall outage trends we've been seeing. So when we look at the total outages in the month of June, we see that the total global outages dropped from 1,305 to 710, which is a percent decrease when compared to May. This pattern was reflected in the US, where outages there dropping from 597 to 310, which is a 48% decrease. This downward trend is actually reflective of patterns we observed in previous years, leading into the Northern Hemisphere summer. And if we actually look at that month there, if we're looking at the graph, we can see we can actually see a reasonably flat lining. So if we look at these outage fluctuations week over week, the global outage numbers across the entire month of June are reasonably stable week over week. We didn't see too many dramatic swings in outage numbers during this month at all. In June, we also saw a continued trend of US-centric outage numbers accounting for at least 40% of all observed outages in a given fortnight. We didn't see such high percentages earlier in the year, but since April, US-centric outage numbers have been 40% or higher of all observed outages. This percentage did decrease a bit throughout June, but never dipped below 40%. So just to cover those numbers, where US-centric outages accounted for 44% of all observed outages from June the 5th to 18th, which is lower than the percentage observed between May 22nd and June the 4th, where they accounted for 47% of all outages. And again, as I said, it dropped a little bit, again, when we're looking for the following period, so June 19th to July 2nd, where US-centric outages accounted for 41% of all observed outages. This kind of goes in line with what we've actually seen with the numbers dropping. And again, we didn't really see too much global impact from these network outages. A lot of the time of day where they're occurring was outside of business hours. And as we've talked about in previous episodes, we didn't see this radiation of problems or outages impacting too far down the stream there. So in all, although the numbers were they're up, we look from year over year, they're also fairly stable as we go into June. So that's the numbers we're actually looking at for this week. So with that, let's take a look under the hood. All right, so the first outage you want to look at is that Microsoft Teams outage. On June 28, Microsoft made a configuration change to its Teams collaboration platform that caused users to be shown this message, which was operation failed with an unexpected error. And during the outage, users could still reach the front end of Teams, but but they couldn't actually do anything beyond that point. And what we want to do now is just dive into that to see what we saw within an actual test from Thousand Eyes. And Brian, would you want to take us through that?
Yeah, absolutely. For all you listening on audio only, we're jumping into the Thousand Eyes platform here, just showing an example share link of the platform itself, just to demonstrate some of the network tests that we were running during this event. So that's kind of what we're showing here. And yeah, so this was an interesting one. As Mike was saying, when we saw the outage, it wasn't exactly, the front end was still reachable, but if you looked at the actual services themselves, as shown in this test here, we then started seeing some dropouts and, some of the services not being reachable. So what you're seeing here is a page load test, which is actually where it tries to render the page as if it were a user trying to get to that page. And we can see here from multiple viewpoints, the actual objects on the page weren't actually loading. So there's a dip here along the timeline. You can see that the objects weren't actually returning. And then if we go to our waterfall view as well, we can see what was coming back, and that was that 500 error that the application was actually returning. So it's pretty interesting to see that even though the front end was reachable and you can connect to the application, we're seeing a lot of reliance now on microservices and different components being deployed. So now, even though you can get to it, doesn't necessarily mean that it's actually functioning anymore.
Yeah, that's interesting there. And then because normally when we see a page load time drop down, you go, no, that's great. We dropped from 2 seconds down to 50 milliseconds and there. So if I was to look at that without any other context, I'd be going, great, my page load time's improved. But the fact then, as you say, that the components have dropped as well, we're going, okay, we're not loading all 20, 21 components, whatever has actually made that page up.
Yeah, that's a great point. And yeah, sometimes it's a little misleading because you think better performance has got to be better, but actually in this case it wasn't there. And if we look over, we also have an HTTP view, which is just testing the HTTP response. We actually then also see, you can see everything lit up in red here, and then we see those. If I go over the table view, we get our 500 responses. So that's exactly what it was seeing. When it was serving up that error in the application, that's actually what was coming through. So yeah, pretty interesting to see the drop in availability there due to the actual objects not coming back and the services not rendering the Teams content.
It's very, very interesting there. And also, while we're on that there, I love that. So first of all, if we go back to the map, you can actually see, like you said, all the red type of the dots around from there. So these are our vantage points from there. And then we're seeing this is global. This is a global impact. So it impacted everybody. So that is indicative to me that, okay, this is more likely to be with the application within the network. Now, I know we can see that in the HTTP layer. So we're seeing it at layer 4. So, okay, yeah, we can know we're actually looking from there. But again, it's actually a good visual aid.
It is, yeah, and it helps you quickly identify, is it something between my location and somewhere else, an ISP along the way, but if we're seeing it, entirely across the map, then yeah, it's got to be an application error most likely.
Yeah, that's right. It's not me, it's you type of
exactly.
Situation. so we go there. The other one, let's take a look at that, how that outage occurred as well. Again, I'm big on patterns. I'm a very simple man, but I like this step. So we're looking at availability, and we can see sort of steps. So Microsoft told us that they did a configuration change. So I think if we actually go from here, we can sort of see almost how that configuration change was implemented as we saw these steps coming down.
Yeah, that's a good point. So we can also see along the timeline here. So as you were saying, everything was running at 100% here. Page load time was as normal as it was before, and then these little red dots along the side or along the bottom is when we started seeing those errors coming, and that's kind of when that change you could see started cascading, cascading down, and the services started becoming unreachable. The purple dots here, or purple squares rather, are actually showing when we detected an application outage. So the platform itself detected that there was some availability loss and reachability from the agents. So that's actually where we detected that. And then, to the point before about the page load time going down, that's what you're seeing there. And then to the remediation efforts, once they identified it and they said that they actually rolled back that change to start recovering the service, you can see here where the green line starts going up again. That's where the agents started recovering. So whether it was, they did it region by region, or, whatever their rollout was to undo that change, that's where we start seeing that upward trend and then getting back to 100% availability, which is when the outage was over.
Yeah, that's cool. And actually, you're right. Hindsight's a wonderful thing. They told us it was a rollback, and we saw that. Like you said, where they did region by region, but we could see as it comes through, we do it, the regions came, so what was red now became green in that reverse order. So it was actually pretty cool to see.
Yeah, absolutely.
That's cool. The other interesting thing about this is, and I know we're looking here at specific Teams a test here, so we're looking at Teams there, but also what we saw across the broader set when we're looking at the Thousand Eyes Internet Insights platform as a whole, we actually saw this was really only impacting Teams itself. So if we normally talk about, and we were talking about dependencies and different architecture, we think about Teams as part of the, or is included within the Microsoft 365 suite. From there, or a set of products there. And there's lots of aggregation points within that, so we're doing authentication. But this seemed to be something very specific to Teams itself.
Yeah, and it's interesting because, like you said, a lot of times we'll see whether it's a configuration change or something on the app side that all services will be unavailable, like Office 365, just as a whole, or whatever provider it is. But yeah, this one seemed, very specific to Teams, which again can kind of help you narrow down, a specific application change where it wasn't like, log into a platform, or it wasn't, a front end service. This was really just kind of a back end configuration change for, specifically for the Teams service, which was interesting.
Yeah, that's good. And just before we leave this, just a point, I actually really like the idea of how you've got this shown here. So again, for the audio listeners, what we've been able to do is we've actually sort of been able to stack sort of metrics against each other, so you can actually really truly correlate them together. So I can actually come straight through, you can see the page load time and then look at the availability as well. Really, really cool view.
Yeah, definitely helps with correlation.
It does. All right, so thanks, Brian. That was actually really good. Now, sticking to that front-end contactable and loading, but some services not functioning, let's just discuss the GitHub outage. So on June 29th, GitHub users experienced a nearly 45-minute disruption. In this case, GitHub's page rendered normally, but the back-end service, the systems and products the users trying to run from the GitHub page were not responsive and appeared to be unreachable. Now, in this case, GitHub have provided quite a detailed post-incident report where they go through and where they've stated that they were testing a new failover mechanism that had a network path configuration issue that prevented it from properly functioning. Now, this actually caused issues with internet connectivity to GitHub. So differing, as we saw, Brian, within the Microsoft Teams, we said it was the application. This was actually impacting the applications. But if you actually looked at it, what we're actually seeing was that the loss rate we saw as a loss because of the network path connectivity, but it was within the GitHub's environment, which you can see those losses coming up from there. So do you want to just sort of briefly explain the difference between a back-end network, I guess? So we're sort of routing traffic around or forwarding traffic within an internal environment, to what we were talking about if we had a network issue across the internet itself. So basically what I'm saying is, in shorter form, is why would this manifest itself as an application issue as opposed to sort of what we would typically call a network issue?
Yeah, sure, absolutely. So when you're looking at a front end network, right, that's your connectivity between home machine or wherever your location is to the initial point where you enter into that provider, so to the application. So in that case, a network outage would be along the way, either with your home ISP or with a transit ISP that you take to get to that front door. On the other side, a backend network is going to be something inside of a provider's data center, or kind of once you get inside that house, it's something internally there that causes a problem. And a lot of times now, with so many connected services, we see issues where they're segmented on different networks, or the applications are separate, and that's when we see, in this case was a really good example of it, there were backend network changes that were to blame for some of this. So that's really the difference between when you're looking at a front end change where you actually can't get to the application, versus you can get to the application, but the application itself can't do anything because it has the network problems on its back end.
Got it. So that's then why we saw packet loss. So the request was simply timing out. So we're getting no response back. Whereas when we're looking at the Microsoft one, we saw 500 status codes because exactly. I was getting a response to the server. Yeah.
Yeah. You don't know any better because you don't actually see that. All you can see is the app isn't loading. Whereas on the network side, you can't actually make that connection.
Well, thanks for taking us through that, Brian. That was really great.
My pleasure.
All right. So that's our show. Please like and subscribe. We really appreciate it. And it's valuable to us. As I said, as I mentioned at the top, not only does this ensure you're notified as soon as a new episode is available, but also helps us in shaping the show for you. As always, follow us on Twitter at ThousandEyes. And any questions, feedback, guests, please send us a note at the internetreport@thousandeyes.com. So until next time, goodbye.